Hello everyone, welcome to Triaright, the new era of learning. This is Pack 365 in Module 6. Today we're going to learn about polynomial regressions in machine learning. Let's begin the topic. Polynomial regression is a form of linear regression where the relationship between the independent variable x and the dependent variable y is modulated as an nth degree polynomial. It is useful when the data exhibits a nonlinear relationship, allowing the model to fit a curve to the data. So here we know the what is a polynomial regression, right? So we have a polynomial regression in the form of linear regression, where the relationship between the independent variable x and the dependent variable y. Okay, so it modulated has nth degree of polynomial, right? In simple linear regression, the relationship is a straight line, right, represented by the equation. Like we have like we have some we know the equation of the polynomial y equal to ax plus b. Like that, we have the y equal to beta 0 by beta 1 x and b plus e, right? So in polynomial regression, we introduce the higher order terms of the independent variable. For example, second degree quadratic polynomial regression, like we have it increases the terms, right? In second degree, in first degree, it increases the terms. Like we can say that here we can write here. So in first degree, we have like only relationship between the straight line represent. Only straight line represent. We have y equal to like we take a instead of beta, we take a 0 plus a1 x plus e, right? So this is our first form, right? So instead of that, we can take like this also. So in second term, in second degree quadratic, we have some like this. So like y equal to instead of a0 plus same like that. Continue with a1 a1 x plus a2 x and a2 x square. Okay, a2 x square here, and again plus it is second term. Okay, so again like this, we have e. So, in third term, like in degree polynomial regression, like now it's the final term of the polynomial regression. So here we have y equal to a naught to a naught plus a1 x plus a2 x square. Here we have plus. So and up to nth term, right? Up to nth term, like a n of x power n. So up to we have for nth term. So this is the equation of the polynomial, right? This is the main equation. This is the main equation of the polynomial regression. Okay. So in that we have why it is useful for primary reason to use polynomial regression is when the data exhibit for a nonlinear relationship. If you plot your data and clear show a curve, example U shaped and S shaped, like we have a or a generated general bend. Okay, general bend we can say that. So usually we can say that we all know that linear regression. First, we have talked about linear regression, right? So linear regression, we have like that. Okay, so we have dots, theta dots. So like that. Our line must be transfer straight, right? So our linear line should be straightforward, okay? So in polynomial, what it happened? It curves. The line will bend. Okay, the line will bend. Okay, like that. It curves the bend like quadratic equation like that. So here we have a need for polynomial regression. So here we have what we have the nonlinear relations some type. So a non-linear relationship polynomial regression is used when the relationship between the independent variable input and the dependent variable has output. So in that is no relationship. Okay, unlike the linear regression which fits a straight line, it fits a polynomial equation to capture the curve in the data, right? So here what we're saying in many real world scenarios, the relationship between the variables is not in a simple straight line. For example, growth curves efficiently of a machine with temperature or the relationship between the experience and salary might follow a curved path linear, okay? Regression which assumes a straight line relationship would be poorly represent such data, okay? So next we have better fit or curved data like it either when a researcher a hypothesis a curve line linear relationship polynomial terms are added to the model. A linear model often the result in the residual with the noticeable patterns, right? Which shows the poor fit. So what the when a scatter plot on of your data is clear show of a curve linear patterns, a polynomial model can be bend, like we can say bend to fit the curve much more accurately on the straight line. So here we have flexible and the complexity by so it does not assume all the independent variables are independent by the introducing higher degree term. It allows for the flexible and can model more complex curve linear relationship between the variables. Yes, by introducing the high degree terms like x1, x1 square, x1 2, x power of 1, x power of 2, x power of 3, and up to the nth term. So polynomial regression offers the greater flexibility to the model of more complex curve linear relationship that simple linear relations like and the cannot it allowed the model to capture turning points or a local like maxima or minima, we can say that. So here we can say this is a linear regression point. Okay, this is a linear regression point of the term, right? So it follows the straight line wheel. So difference between the simple linear model and polynomial model, we can see here whenever we transport the we see the line here. So whenever we see the line here, it is a linear line, okay? It is a linear line. It follows the straight. It follows the straight, okay? It follows the straight. But when it comes to polynomial, it literally curves because it has only one formula. Like we can say that y equal to ax plus b. So we have we already see in the previous lecture. So what is a linear model equation? Y equal to ax plus b. So like that, instead of this, we can say the linear function of the model. So linear function formula. So this is a simple linear. Y equal to like we can say that instead of b also we can take a also. So a plus a1 x like that. So here we have bend model. So it little bit bend the line polynomial. Okay, same code, but it just bend. In linear we see the straight line. In polynomial we see the curve line. So the goal of the regression analysis is to model the expected values of a dependent variable y in terms of the independent variable x. In a simple linear regression, this relationship is modulated as y equal to a plus bx. Okay, a plus bx plus e. So here, so y is the dependent variable here. A is the y intercepted, and b is the slope, and e is the error term. Okay. So, same like that, polynomial regression is an extended of a linear regression where the higher degree terms are added to the model non-linear relationship, the general form of the equation of for the polynomial regression. So here we have this. This is the main polynomial equation formula: y equal to a naught plus a1 x power of 1 plus a2 x power of 2 plus up to the nth term a power n a n plus a power of x power n. So this is up to nth term. It's like polynomial. Okay. So where here y is the dependent variable, x is the independent variable. We all know. So here a naught, a1, a up to nth term of an or the coefficient of the polynomial terms. Okay. So here n is the degree of the polynomial and the e is the represented the error term as usual. So this is a simple linear regression formula and this is a multilinear regression formula and it is as a polynomial regression formula, right? We have this, we seen this formulas in previous lectures. Okay. So whenever the data comes to the polynomial, it simply first check the pipeline the view. Whenever it takes the draw data and the polynomial designs for first it designs the polynomial transform. After that, it converts to linear regressions, like it performs the polynomial transfers and logistic and more of the multilinear regressions. So it performs some set of operations and then it convert the data into the then it moves to the linear regressions, then after it predicts the data. So if you see the equation of the polynomial regression carefully, then we can see that we are trying to estimate the relationship between the coefficient and the y, right? So, and the value of the x and y is already given to us and only need to determine the coefficient, and the degree of the coefficient here is 1 only, and the degree of the represents simple linear regression. Hence, polynomial regression is also known as a polynomial linear regression. So nothing but I hope you understand. Difference between polynomial and linear. Linear forms the straight line and polynomial forms the curved line. So a little bit in change of formula, remaining all the code instance of same. So I hope you guys and all of you understand this. Thank you.